Okay, so for this one, again, we're going to have to use, what we know about trigonometry. So we're going to make a right triangle. So let's do that. Right, remember, we want to make a right triangle with that angle theta, so that tangent of theta is 2/5. Now, we know that tangent of theta is opposite divided by adjacent, right? Right? We have this triangle as well, reminding us. So tangent of theta is 2/5. All we need is a right triangle so that this equation holds. I put theta down here on this angle. Although really I could have done it up, I could have put the angle up here, but I didn't want to. Okay, so what can we do? Well, we could make the opposite side length 2. So in other words, I'm going to replace OPP by 2. ADJ here, the adjacent side, that's going to be 5. Okay? That's going to be 5. So we're going to make the opposite side 2, the adjacent side 5. So OPP is going to become 2, ADJ becomes 5, as in this slide. Okay? So we have this right triangle. And here, from here, you should be able to see, using SOHCAHTOA, that tangent of theta is opposite, which is 2, divided by 5, which is the adjacent. I should say this, I said it for the other class. If you have this kind of equation, you don't have to have the numerators be equal and the denominators be equal. They can be, as what we're doing here. But if two fractions are equal, their cross products have to be the same. Okay, it's just something I mentioned it in the other class, so I feel better mentioning that here. But you can assume here the opposite side is 2 and the adjacent side is 5. I'm just saying this doesn't normally have to be the case. But anyway, hypotenuse, right? We have to figure that out. We don't know what that is. So I just called it x, the hypotenuse, the length of it. And how do we get the length of it? Well, we can use Pythagorean's theorem because we have a right triangle here, right? So that's why. Okay, so from Pythagorean's theorem, we know that 2 squared plus 5 squared is x squared, which is equivalent to writing this. So we get x squared is 2 squared plus 5 squared, okay? And so we have x squared then is 4 plus 25, which is 29. So x squared is 29. Thus, x is the square root of 29. And you don't have to simplify this. In fact, you can't, because 29 is actually, its only factors are 1 and itself. In other words, it's prime. Okay, so this is our right triangle here. So this is our right triangle. All right, that's good, that's good. So from here, we can now get all the trig functions. Sine of theta, right? Opposite divided by hypotenuse. So the sine of theta is opposite, which is 2, divided by the square root of 29, which is the hypotenuse. Right. Cosine of theta is adjacent, 5, divided by hypotenuse, radical 29. And tangent of theta, we know, is opposite 2/5, adjacent. All right. Okay, that's good. For these here, these are actually the reciprocal identities. It's not the definitions. It's not the formal definition of cosecant, secant, and cotangent, but that's okay. And when you have 1 over sign, that just means you take whatever sign is and flip it. Take its reciprocal. Its reciprocal here, the reciprocal of this is just radical 29 over 2. That's all it is. Secant theta is 1 over cosine, right? So what do? You flip this. You flip whatever cosine is. So you have radical 29 over 5. And cotangent, we know, is 1 over tangent, which is taking whatever tangent is and you flip it, you invert it, you get 5/2, which is good. All right, good. Any questions on this one? Okay. Well, for this kind of question here, okay, for this kind of question, what we have a certain angle, and we know one side. We want to get the other sides. So, for instance, here I'm telling you that this angle is 25 degrees. I know the triangle's not drawn to scale, but that's okay for now. We know that B is length 5. B is length 5. Okay? What do we do here? Well, okay. So we want to get A and we want to get C. We're going to get C without using A. Basically, in other words, we're not going to use Pythagorean's theorem to find C. I mean, theoretically, once you know 2 of the side lengths, you can theoretically use Pythagorean's theorem, but we're doing trig here, so we're going to use trig. So how would you get A? Well, notice that, let me get the pen out. Notice that B is the adjacent side. A is the opposite side relative to 25 degrees. So we have opposite and adjacent. What trig function? We're going to use tangent. We're going to use tangent. Okay. So tangent is what we're going to use, right? In fact, tangent of 25 degrees of the angle is opposite divided by adjacent. Okay, it's opposite divided by adjacent. So in this case, it's going to be A divided by B. But we know what B is 5, so we actually have this. I mean, we have this here, but since B is 5, we get this. So tangent of 20, so we have this equation, tangent of 25 degrees is going to become A over 5. Now, how are we going to get A, though? Well, we just cross multiply. As in the next equation, right? You can multiply both sides by 5. This denominator goes away, and we're left with tangent of 25 degrees times 5 equals A. Which, of course, is the same as saying this. 5 times tangent of 25 degrees is A. So this is what we get. Okay, so now this is where you want to use a calculator. 5 times tangent of 25 degrees, okay? Just make sure you're in degree mode, okay? If you're in radian mode, the calculator's going to think you want tangent of 25 radians, but that's not what we want. We want 25 degrees, okay? And I'll tell you how many decimal places to round to. I used 4 here. Here I used way more than 4. I think I used 9 actually. Okay. I mean, you could use 9, you can use 8. You want to use more than what I tell you to round to in the end. So then, of course, you multiply this by 5, you get this. So the answer is 2.3315, it looks like. That's what A is. Okay. How about C? Well, from here, can we get C without using A? We know B, right? B is 5. We know that, and we have 20 for the angle here. B is the adjacent side, right? C is the hypotenuse, as you can see. So we have adjacent, hypotenuse. We're going to use cosine. Cosine. So cosine of the angle is adjacent divided by hypotenuse. So cosine of 25 degrees, that's going to equal to adjacent, which is B, divided by hypotenuse, C. And B we're assuming is 5, so we get this. Okay. Now, we want to figure out what C is, right? So, well, from this equation, we actually have this one. We want to figure out what C is. Well, how do we get that? Well, we can multiply both sides by C. That's how this equation comes about, right? If you multiply both sides by C, this cancels. You're left with cosine of 25 degrees times C is equal to 5, which is the same as this. We're not quite there yet because we want to get C all alone. What you can do is divide by cosine of 25 degrees. Both sides by cosine of 25 degrees. That's what this equation is, and when you do that, these are going to cancel, as you can see. We get C equals 5 divided by cosine of 25 degrees. And of course, the cosine of 25 degree part you could do in your calculator. That's what I did. We do 5 divided by this. And so we get C is about 5.5169.